let us proceed with the review. So let's start with these guys. What do we call these bad boys? Braces or brackets. You got it. We use these when we are declaring code for a function. So basically, if we were to declare a function such as void setup, any code that would be contained within this function, or so in this case size, would be encapsulated in these nice little brackets. So that's all that is. Which command drew this line here? Not specific numbers, I'm just looking for the overarching command. Yeah, it's very simple. It's just called line. So the syntax for line is just based on your x and y endpoints. So for example, this is a 500 by 500 size GUI box. And one endpoint is going to be the center point, which is 250, 250, and the other is 0, 0, which is the origin right here. So anyone remember what GUI means? GUI. Nobody? That's alright. It's called a graphical user interface. It is not gross and slimy usually unless you code it to be gross and slimy, but graphic user interface, that's officially what GUI stands for. So we discussed how you can either use 3 lines to create a triangle or just use the triangle command, which is defined by its corners, so it's x and y coordinates for the corners. And we also discussed going into tools and then color selector, so that we can choose colors for our background. Again, these are going to be RGB colors standing for red, green, blue, which we can then declare in our void setup loop to make a certain background color. So again, these numbers are going to range between 0 and 255. We also discussed the ellipse command, which is defined by its center point, which in this case is 250, 250, just the x and y coordinates, and then defined by its width, which is horizontal, and its height, which is vertical. So in this example, we have an ellipse centered at 250, 250, which is the very center, and we have a 100 pixel width and 100 height, which means that this special ellipse is a circle. We then discuss the rect command, which is defined by its upper left-hand corner. So that's the first 2 bits of syntax here. So 300, 300. And then we discussed its width, which is 100, and its height, which is just 25. So does anybody remember how we would set up any code? So just the very, very, very basic functions to get code working. This is going to be in just about every piece of code we work with. So there's one. We got our void setup. So not this. Don't worry about this. And it's open and close brackets. And what else is there other than void setup? It's going to be void draw and these same curly brackets. I would like for you to write this down because we are going to get started based on what you see here, and I will go to this next slide, which actually shows this bigger so you can actually see it. So I'm going to put hands down. Please raise your hands once you've gotten processing opened and you've gotten this bit of code written down here. We will be basing the code we do today off of this code. If you did attend the earlier class, not today, but last Wednesday. You will have done this already, and it should be saved under Move. But don't do that yet if you didn't do the 4 p.m. class last Wednesday. We're just gonna start this. Very simple. You're done. Awesome. Give it just a second before I continue. Because today we're going to get to a bit cooler of a point than we have been so far. So far we've just been making shapes, which is fun and all, but it's not quite there. You say your computer's turning on. Oh, right, because you're on different things for talking and for... Yeah, okay, gotcha. So if you feel confident, go ahead and set up your GUI size and your GUI background color. Only if you feel confident doing it. If you don't, I'll show you the code in a minute. If you're just now coming on in, we're opening up processing, and we are going to write all this stuff that you see right here down, which should just be the very baseline code that we will be using in almost everything we make in processing. And please raise your hand once you've gotten all this written down. You were stuck in traffic. That's okay, no worries. We haven't done too much yet. We just reviewed so far. Just go ahead. You should be able to copy and paste just that into your processing sketch. And here's where we'll get some more stuff started here. So like I said, we are going to be defining our GUI size as well as our background. But I do want you to choose a specific GUI size. In this case, we will be messing around with things that require a bigger size than just the 500/500. So in your void setup loop, we're going to size our GUI by using the size command and make it 1000 in width and 750 pixels in height. And if you've already gotten this, what are these guys called? These guys are semicolons, and they'll be in almost every single piece of code, or every single line of code that you write, with a couple of exceptions. What's the equivalent of a semicolon in a book? Or what's the equivalent of a semicolon encoding, but inside a book. There we go. It's basically like a period, telling the computer, hey, let's go to the next sentence here. Exactly. So finally, let's go ahead and add a background within the void setup loop. And in the void draw loop, we're going to draw an ellipse. I would like for you to keep the values of the ellipse the same as you see on your screen, but you can choose whatever you'd like for your background color. So before I go any farther, I do have some questions I see here. So you're asking, where are we? So what we're doing right now, we are just starting a very basic line of code. What I want you to be doing right now is writing down literally what you see right here. So that's going to be our void setup, our size, our background, void draw, and our ellipse. What I'm going to do, actually, in 1 second, I'm going to send you the entirety of the code that you see on the screen, but I myself have to finish typing it out first. Okay. So what you need to do is literally just copy and paste this into your initial, or into just a blank processing page. And I'll send it in the chat for everybody too, so. Y'all can double check your code if something's going weird. I like the worm you made, Gavin. There's only more where that came from, too. So remember, you don't need to type this big stuff or anything. You're just looking at this stuff right here. I would like for you to raise your hand once you've gotten that entered into a blank sketch on processing. Alright, that's alright, Elijah. No worries. What's up, Mateo? So I did just put hands down, so no worries. Don't worry about it. No worries. Ignore me. Yep, perfect. So you'll see something looks like this. It depends on what background color you've got, but otherwise it should look spot on, as it does here. So we're going to add some stuff. Oh, you made yours more blue? Oh, I didn't see. I didn't notice the exact RGB values you had. So we're going to add some stuff to this, and I'm not quite going to go over what this stuff means just yet. I want you to see how it reacts. we're just going to be adding 3 things. The first, before void setup, we're going to add this right here. int x semicolon. In your void draw loop, above the ellipse, you're going to type in x plus plus semicolon. And for the ellipse, you will be changing the 100 to an x. Random, what do you mean? Are you asking if what we're doing is random, or you're talking about color-wise, the background? So it looks like Gavin sees what's going on. What do you see on your screen? What's going on there? It's not... It's, did you make sure to add this extra intx at the top? So I see a couple of right answers here as to what's going on. I just want to make sure that everybody gets this entered in right. Here to address any issues. Your screen's going to look a little bit weird. And that's what it's supposed to do. It's going to make a real weird thing going across the screen. That circle you made is going to go across the screen and it's going to leave a really gnarly trail there. And it's going to keep going off the screen until it reaches the end of the universe, or we stop the program. Is that what you saw? Everybody got that? If not, it's okay. Stop me now. Some weird stuff. It's not solving for x. No, definitely not. I'll tell you how this works in a second. Actually, if you've done any coding before, does anybody have any ideas as to what's happening here? If you do, go ahead and tell me. Any ideas as to why it's looking all weird and wormy? Remember what the void draw loop does? It is supposed to happen, because that's how we coded it to happen. I mean, we don't want it to happen, but that is how we coded it to happen. Alright. And that's okay. I haven't explained anything yet, so if you had any experience coding, it would make more sense, but you don't, so that's what I'm here for, to help you learn. So let's talk about what the code is doing before you take a guess. So what we're doing, the very first line before the void setup, we're doing what is called declaring a variable. So that's what the int x stands for. So specifically, the variable that we are declaring is called an integer, so it's a number like 1, 2, 3, 4, whatever. But specifically, if we don't assign this variable a number, it's going to start at 0. So what we're saying is, hey, we have this this variable here we're going to be using later on in our code. We're just telling the computer to look out for it. So this number actually can change throughout the life of a code, just sort of like how the time of day in Minecraft is not always daytime. So all that we're doing with this first line is declaring a variable so the computer knows what's up. So this x++ line is a little bit different. We call it an increment operator. Whenever the code sees this x++, it will increase the value of x by 1. So if y'all remember, the void setup loop only runs once, but the void draw loop is going to run more than once. It's going to run infinitely, over and over and over and over again. So each time that the void draw loop repeats and sees this x++, x is going to go up by 1. So the first time it runs, x is going to be 0, the second time it's 1, third time it's 2, all the way infinite until the world ends, or we stop the code. Alright? So hang on, I got a whole bunch of questions here. Oh my goodness, what's even happening right now? And no worries, Jen, no worries. What are you doing? Why are you spamming me here, Gavin? The code is right. You're adding extra rectangles. But real quick, can you use more ints for later use? You can, definitely. So let me explain what this last x does after I send the code. I'm sending it in the chat. So Jen, since you were a little bit late, what you can do is just copy it and paste into processing what you see there. Oh, they're 3 different ones. Okay. It's just looking like you're adding some extra. Okay, I see what you're doing there. Alright. So for this last change that we made, we put an x into our coordinate system, or into our coordinate declaration. So remember, the syntax of the ellipse command is x and y coordinates for the first 2 numbers, and then the width and height of your ellipse. So by changing this first number to x, we're literally just changing the x coordinate at which your circle is at. If we put this back to 100 and change the y coordinate to 100, what would happen? Wild guesses. Just go ahead and shoot them. What would happen if we changed x back to 100 and y to the y coordinate to the variable x? The computer won't explode, fortunately. The computer is very good at handling stuff like this. The same thing's actually going to happen, except the circle would go down, because the y coordinate would be changing. Exactly. It's going to go down instead. Excuse me. So now what we want to do is get rid of the trail. That trail is pretty unfortunate. It's not very visually. It's kind of cool visually, let's be real. But if we're making a game, we don't want a trail to be behind everything that we're creating, right? It would make it very hard to see. And yeah, I agree. I do think it looks really cool, and there's cool stuff that you can do with it, but we generally won't want the trail. So what we're going to do is change where we declare our background. If y'all remember, the void setup function only runs once, and the void draw function runs forever. So what's happening is once the background is set up, the computer is constantly going to be drawing over this background, and not eliminating the drawing that it did before. It's just constantly drawing on top of each other, just one pixel over into eternity. So we're going to move the background declaration into our void draw loop. So if y'all remember the cut and paste that I talked about both of the last classes, we're going to highlight the background, hit Control X on a PC and Command X on a Mac, and just above this X++, we're going to paste our background declaration. Any hypotheses why we would do this? Why are we moving it from there to there? What's special about the void draw loop? It loops over and over and over and over and over again. So what's happening is the ellipse is going to be drawn. After it's drawn, this void draw loop is going to kick it back up to the beginning of the void draw loop, and it's going to redraw our background. So real quick, let me update my own code here. And notice that the background's constantly being redrawn to get rid of that, the previous drawing of the ellipse. So it's not as cool, but I think it's still pretty neat. So what I want you all to do now is go to File and then Save, and I want you to save it as Move. Because what we're doing is making something move. Any questions on what we've just did right here? So just adding some more ellipses to yours. All sorts of ellipses, it looks like. Any questions here? Alright. You've got a ton of ellipses up on here, that's crazy. So let's go more into depth about this. You should have saved this as move. We're going to keep working on this one. But what we'll notice is that our circle is going to keep going off the screen. Why does it continue to do this? Why doesn't it stop when it senses the screen's there? Not because over 9,000, the computer will actually have the circle going on into infinity, because we haven't told it to stop when it hits the corner. We've told it to keep going forever. So we can fix that. Computers are real stupid. We have to tell them everything. So before we fix that problem, let's add some text into our void draw. Yeah, just like your dog. It's going to keep going forever until you tell it to do something else. But in our void draw loop, we're going to add some text here. So just like before, when we filled in the colors of our shapes that we created, we have to declare our text size first. If we don't want it to be the standard, we won't have to do this, but we're going to change our text size. So when you write text size down, make sure to capitalize this S. So text size is going to be 32 and a semicolon. And then the next line, I want you to copy it exactly as you see it there. There's a reason I'm telling you to do that. So you got to include the quotation marks. So setting the size first and writing the text somewhere on our screen saying this is a circle, and then we'll be defining the x and y coordinates at which we would like the top left of our text to begin. So while you're typing this out, the text within the quotation marks is called a string. So a string is basically some code that, or it's not code actually, it's read by the computer as to not be code. It's sort of like a comment, except the computer doesn't skip it. The computer actually realizes, alright, my programmer is telling me to do something, I need to include this, and so it will include it on your screen. But it's not reading it as if it's code. It's reading it as if it's an image, basically. It's just saying, hey, we're going to put this on the screen. When we use these quotation marks, that's always going to be a string. So it's not okay, I see what you meant there. I didn't get that pun at first. It is a small rope, but in this case, a string is just going to be a string of letters that the computer will not read as code. It's more like an image. Any questions on this? Go ahead and raise your hand to indicate to me that you've gotten everything you see on your screen written down. So if you've gotten all this written down, I want you to consider, we're going to do this in a second, how would you make your text move diagonally across your screen? How could you do that? I just want you to give it a try before I go on. So that's a good thought. You could change the 10 to 100 and the 30 to 50, but that's only going to do something once. It's going to change where the position of the letters are on your screen, but it's not going to make them move. So definitely a good thought. So I do see a good answer here. Just like with our ellipse, where we could make the starting point change every single iteration of this void draw loop, we can do the same thing for our text. But instead of changing just the x, or just the 10 to an x, if we change both of them, we can actually make it go diagonally. Yeah, perfect. So let's go ahead and change both of our both of our coordinates for the text to x and x. And take a look-see there at what happens. Going pretty darn slow, but it's still moving on forever and ever and ever. So that's a wonderful question. And that's exactly what it's going to do. It's going to make these words go diagonally. Now the question is, how do you make it go faster? And that is going to be the next thing that I go over. So let's talk about that. Let's talk some. Well, before I do that, it's going to be the second to next thing we go over. I want you to type in, underneath ellipse, the word print, a lowercase letter L, and a lowercase letter N. Open parenthesis, X, close parenthesis, semicolon. This vertical letter here is a lowercase L, not an I. So that's not going to do very much right now. It's really just for your personal reference. But what it's doing is it's going to be printing in the console, which you can see at the bottom of your screen, right there. It's going to print in your console what your current value of x is going to be. So you can actually see it increase, just so you can sort of get an idea of where your x value is going to be. And it shouldn't make it go any faster. It really shouldn't. It should be going the exact same speed. And if it's going faster, that's interesting. I need to look into that. So this is only for your reference. So you don't really need to worry about it, but it is handy to have in your arsenal. So now let's talk about how to make this go faster. So remember this increment operator that we put in earlier, this x++, it's only going to increase x by 1 for every iteration that the void draw loop goes. So let's make it increase by more than 1. So what we're going to do is go into our void draw loop and delete this x++. We're going to replace it, well, sort of replace it with something else. So all we're doing is deleting this bad boy. Yours stops at 226. Huh, it shouldn't, because I'm already at 2280. It'll stop wherever you tell it to stop. So we're just deleting the x++. And instead what we're going to do is add a couple more things to it. We're going to add another integer. We're going to declare our integers, or we're going to add another variable, sorry. We're going to declare these as specific numbers, and we're going to add one more line. It starts at 729, huh. Interesting. So what we're going to do is, underneath where we declared our x, we're going to declare another integer called speed. is all outside of the void setup loop. We're going to declare within the void setup loop x to be 0 and speed to be 5. Within our void draw loop, we're going to add this little guy here, x equals x plus speed. So like I said, all this is going to do here is declare a new variable called speed. We're verifying that x is going to start at 0 and our speed is going to be starting at 5. But the real meat of this code comes where the x equals x plus speed comes in. That's going to be the real big portion of the code. Y'all ready for this? Alright, I'm going to talk about what this guy's doing right here. So, I've set it. It doesn't move. It should be moving. Just send me your code. So basically what we're doing here, if you all remember, I've said it 50 times today so far, the void draw is a loop. It's going to be repeated over and over and over and over and over until we make it stop. Oh, it's because you didn't include this x equals x plus speed. That's why it's not moving. So what's going to happen, what this is doing, it's just reassigning the value that x is equal to. So it's sort of like the x++, but we can actually increase the increment by more than just 1. So what's happening here is the first time this void draw loop is run, we're going to start with the x value that we set, which is going to be 0. We're going to add speed to it, which is always going to be 5. And that is going to be our official x value for this iteration of the loop. So, initial value, what we're adding to it, final value. So this first iteration, this value of x is going to be 5. So instead of just going up by 1, it's going to go up by 5. So whenever we have this x, this iteration, we're going to change the coordinates to 5. Did you make sure to declare speed up here underneath the int x? If you don't declare it, the computer's going to be like, well, what's going on here? Computers are really dumb. We are their overlords right now, at least. Yeah. So the second iteration that this void draw loop happens, it'll take the x value from the previous void draw loop, which in this case will be 5, and add the speed to it, which is still 5. So for the second iteration, our new x value is going to be 10. Any ideas of what our third iteration x value would become? Not quite over 9,000. Mateo got it right. It's going to be 15. So we're taking the old x value, adding the speed to make a new x value eternally. So then we go 20, 25, all the way till eternity. And you can see this in the console. You can see this if you keep this print line You can actually see this happening in your console here. So yep, just increments of 5 till you stop it, basically. You got it. Oops, went a little bit farther. So does everybody understand sort of what we're coming for here? And this loop goes pretty darn fast. So it's very possible to get to numbers that, you know, are indeed in the hundreds of thousands. The question is, can we see what happens when we change text size to 70? Yeah, most definitely. Go ahead and see what happens. You want to predict what you think will happen? Yeah. Text will get bigger. What happens if you make your speed 50? Hey, you got it, Josiah. And yeah, if you make your speed 50, it's going to go faster. What happens if you make your text size X? What's going to happen there? Because you can do that. Anywhere there's a number, you can put an X there instead. I actually don't know what's going to happen. I mean, I think I know what's going to happen, but let's see if it actually happens like I expect it to. Let's change this text size to X. It's going to get real big. Yeah, right? Pretty crazy stuff, right? It's because you're constantly changing the text size by whatever you're setting your speed to be. So it's constantly getting bigger and bigger and bigger and bigger. In addition to constantly moving, because you've already have these two X's here in your text string. It's some pretty wild stuff. So we still have two more things that we're going to do. You broke your CPU. Yeah, you probably want to stop it before it gets to those high values. Or if there's too much going on, your processor's not going to be happy with you. So we're going to add something else. Text size 9002. Yeah, you probably should do that. Just saying. So in the void draw loop, we're going to add what's called an if statement. Basically what an if statement is saying if a certain condition is met, we're going to run the code within these brackets here. So if you type what you see right here, which is saying if x is greater than width, what we're going to do is change our speed. So just like we changed our x, we're going to change our speed by multiplying the old speed by -1. Why would we do this? Why would that even be a thing? So you didn't miss too much, Gavin. Just go ahead and write this down right here. Unless you want me to send you the really baseline code since you've been messing with it, which I highly encourage, actually. Okay, so I'll send it in the chat. Here is the baseline text we're looking at now. We are adding the if x greater than width thing to it. But let's see what happens when we add this code and run it. Somebody give me what's going on when you do run it. Anybody have any ideas what's going on? Let's go ahead and add it. Let's see what's happening. So let's watch it real quick. Oops, missed something. Oh, there we go. That's what I missed. Watch the circle. Bam! It's gonna bounce right back. Y'all see that? What's gonna happen though is once it bounces back, it's going to infinitely go towards the left until infinity. So we changed it so it's not going to the right to infinity, but it is going to go to the left to infinity once it bounces. How can we fix this? What can we add to this void draw loop to check if our ellipse is too far to the left? You wouldn't use else in this case, but that's a good thought. There we go. We're going to add a new if statement. And before we do that, actually, I forgot to mention, the width that you see right here corresponds with the size up here. So remember what I said earlier, the size is defined by its width, which is the first number, and then its height. Width is actually our first number here. So you can literally just type in width, and it will check to make sure if it's going to be 1000 or not, or whatever size you declare it to be. So if we would like to make it bounce from the other side, we're going to add a whole new if statement. We're going to say if x is less than 0, which is the farthest to the left you can go, we are once again going to multiply our speed by -1. Oops. Does anyone know why we would choose -1? Why are we multiplying this by -1? This is the code we're looking at right now. We're going to change it. We're going to multiply by -1 to change its direction. So remember, we declared our speed at first to be 5. So that's +5. So we're always going to be adding 5 to our x value. If we multiply it by -1, that changes our new value of speed to be -5. So instead, our x is going to decrease in value. Okay, so that's for this first if statement here. We know that the x, or the x coordinate value of our GUI window is going to be 0 at the very far left. So if we do the same thing for this other if statement here, and reverse direction, it's going to look like it's bouncing. So this is a circle is going to go flying off into eternity, but this is going to stay bouncing. Oh, I guess it's not. Oh, right, because... Oh, right, I totally forgot about that. Because the x value is going to be decreasing for a while. What we should have is stuff bouncing every which way. So that being said, it is close to the end of class. I do want you to save as bounce. Really quick, couple things. Send me your code real quick, Gavin. But a couple things. The makeup lab for Charlotte Saturday is on Saturday, which is the 13th. We do not have webinar on next Monday. So we do have webinar in 2 days, but not next Monday. It's President's Day. It's a bank holiday. We just don't have it. And that's the only thing that I had. So once you've saved what you've got as bounce, you can go. If you have questions, I am on to address these bad boys. And let's see what's going on with Gavin's code here. It looks like you literally just copied and pasted what I've got, so I don't know what's going on with that. You're saying it's still not working? Oh, it's because you added an extra if statement, maybe? Hang on. Yeah, you added an extra if statement, Gavin, that's why. You should only have 2 if statements in this one. So, take care, Hannah. Thanks for coming out, and that's for everybody that doesn't have any question right now. I appreciate it. Did that help, Gavin?